Hi, so welcome to our first video for the Bio 110 class. I'm just going to do a quick overview on polar and nonpolar molecules and whether they're hydrophilic or hydrophobic and what that all means. So first we'll go over polar molecules. So polar molecules are polar because of unbonded electron pairs. So our most common example is water. So if we started with water, we start with our oxygen atom, which has 6 valence electrons. And that is going to bond to 2 hydrogens, which each have 1 valence electron. And as you can see now, these 2 electrons each create the bond between the oxygen and the hydrogen. So simplified, this would be drawn out like such. But on the oxygen, we still have these 4 unbonded electrons or 2 unbonded electron pairs. This creates a slightly negative side to the oxygen atom, so this will be partially negative, and in order to neutralize the oxygen atom, these each become partially positive. So polar molecules are polar because of unbonded electron pairs. And our most common example is water. We could do another example of ammonia. So we have our nitrogen, which has 5 valence electrons, and it will be bonded to 3 hydrogens, which each contribute 1 valence electron. And know that for hydrogens, they don't need a full octet. They only can hold 2 valence electrons in their shell. So overall, this will make NH3, and the nitrogen will be slightly negative because of that unbonded pair of electrons. So what this means for hydrophilic and hydrophobic aspects is if you have water and it has its unbonded electron pairs, and this is slightly negative, slightly positive, you need another polar object in order for them to react and not separate. So NH3 with its electron pair, this electron pair will make a hydrogen bond with that, as well as if we had another water molecule, one of the electron pairs would make a hydrogen bond with another hydrogen. If there was a neutral or nonpolar molecule, we would have different results. So we'll go talk about that next. So our nonpolar molecules have no slightly negative or slightly positive charge on every atom. Each atom is neutral. Our biggest and most common example of this is anything with carbon. I'll just do the simplest carbon molecule, which is methane. So CH4, we have carbon which has its 4 valence electrons, and we have hydrogen, which each hydrogen contributes 1 valence electron. Overall, we get every octet is filled. There are no unbonded pair of electrons, so there's no formal charge or unequal sharing of electrons. There's not electrons just around one atom specifically, so it becomes non-polar. Good thing to remember. So methane, ethane, so CH4, ethane, C2H6. These are all good examples. Any of the carbon or organic molecules typically are nonpolar. And so since they don't have a charge, or since they don't have unshared bonds and electrons, that affects how it interacts with water. What happens is if you had methane in water, and so we'll draw our water molecule. Naturally, this negatively charged oxygen will want to bond towards that hydrogen, but in this case, it is not a positive hydrogen, it is a neutral hydrogen. So what happens is we get a thing called a water cage. And these nonpolar molecules are hydrophobic. Meaning that they don't like water. So the water cage is what will happen is if you had a lot of methanes in this water. So we have a mixture of water and methane. What will happen is all of these will come together to one central location, which I'll draw over here. So we have and then I'm just gonna draw this as representation. Since the water cannot interact with them, there will be a water cage and rigidity around this, and they will all clump together because that way it lowers the energy. Instead of a water cage being around each individual molecule, it'll be one water cage around the clump of molecules, and then we will have our water out here that is forming this water cage and not interacting with our nonpolar molecules. So a good common example of this is oil and water. All the oil goes to the top, all the water goes to the bottom, and there's a very distinct layer between where they're interacting but not completely, that they're both close to each other but not completely interacting. So hopefully that helps with nonpolar and polar molecules and hydrophobic and hydrophilic and what it's all about.